Chapter 9, Section 1 involves transformations. And transformations are going to just involve movement, which then results in a change. And there are some different types of transformations we're going to look at. The first is called a translation, and all we're going to do is we're going to move an object along a straight line. Now, what happens here is every point in the object moves the same distance. So again, every point moves the same distance. And same direction. For example, if I have a point and I label that point arbitrarily x comma y, and I move it, both x and y are going to change, and this moves that x is going to move 1 and every y is going to move 4. So it involves an angle and a distance. Sometimes this is referred to as a vector. And a vector has a length and a direction. And we'll be doing some explorations on this so you can see what happens when we give you this vector. And we have some names for things here. A, capital A, is the original shape or figure that we're working with. And then the result of this translation or any transformation is an image of A, which we're going to call A prime. So the image is referred to as A with a little prime, and that's just a little slash. And again, that's called A prime. So what essentially happens is if I have a simple square and I have a vector, in other words, I'm going to move every point on this square in this direction and that length. The shorter the arrow, the shorter the length. So every single point is going to be moved. So what I can do here is I can clone a couple of these things so that I can show every single point is going to be moving in that direction and that distance. So I would want to put it on, I'll just pick the 4 corners here, and we'll put the other one here. And now my new shape is when I connect those arrows, I'll get my new shape. So every point was moved, and again, we'll see that using some patty paper. The original is A, the image, the result of the transformation. In this case, the translation is called A prime. Now we have a reflection. You're probably more familiar with a reflection. All we're going to do is think of it as a flip. So we have this line of reflection. And if I have this line of reflection, and suppose I have some triangle, that's A, my original, and I flip it, it's going to end up, it's going to end up down here across this. And notice that this line is, if I connect these 2 points, it is the perpendicular bisector of a point and its image. So you can see that the line perpendicular here is running right perpendicular to my line of reflection. Now we have this thing called rotation. Oh, and by the way, we should mention distance here. Notice each point was moved the same distance in a translation. In a reflection, the image is the same distance to the line of reflection as the original. So the distance between this point and the line of reflection, this distance, is equivalent to from the line of reflection to this A prime or image. When I have a rotation I like to think of as a spin. You have to be a little careful about the spin because the point can be located in several areas. So what you do is you're going to hold a point fixed, meaning that you're not going to move it. You're just going to hold it, and you're going to rotate the plane about the point. So I hold this point fixed, and everything swings about that point. And we're going to swing at a certain number of degrees. This point that I hold fixed is my center of rotation. So the center of rotation is your fixed point. Now what happens is the original point and the image point are the same distance from the center. So if this was my original point, and I used this as my center of rotation, and I rotated a certain number of degrees, when I go and look, the original point and the image, here's my image, are the same distance from the center point, which is the center of rotation. So you can almost think of it almost like a little circle here. So these distances are going to be the same. We have what we call congruence transformations. Congruence, if you remember, is kind of the word in geometry used for equal. Our congruence transformations are our translations, our reflections, and our rotations. In other words, my image and my pre-image, or my original, are going to be congruent. So my original is congruent to my image. In other words, they're going to match in shape and size. We have a thing called composite. And if you remember in algebra, you did some composite of functions, just meaning you put them together. A composite is a combination of transformations. It's a combo of transformations. Now, when we say a combo, we mean composite. You're going to do more than one. And a famous one is a glide reflection. It's built of a translation and a reflection. So what's going to happen here is I'm going to have a translation vector, which again, if you remember, it's going to tell me distance and direction. And then I'm also going to have a reflection. And you also see this with footprints. So I might have my translation vector. So maybe I have my first footprint. Notice it's not quite an arrow. I'm going to translate it this distance in this direction. And I'm going to put in this line of reflection. So it's going to translate and reflect, and it's going to end up approximately here. Notice I went straight, and it's going to end up right at the end, and then you keep going. So now it's going to reflect back. So it's kind of like the little footprints in the sand deal, and it just alternates over that line. So that's a composite, and if you notice, that also has a congruency. It's the same. So again, translation, rotation, reflection, which we spoke about earlier, and then this glide reflection are going to be congruent transformations, meaning their result is going to be the same shape and the same size. Now we've got this relationship between numbers and shapes, and we'll talk about that in the next lecture. Let's jump down to congruence. Congruence is going to happen only if a transformation that would be the reflection, the rotation, etc., can be used to map one figure onto another. And what happens then, they pair up. Corresponding parts match.